Okay, guys, we have a machine that actually does the same thing as a black hole, suspends time or slows time to a certain point. So anybody inside this object or this machine will actually be in suspended animation to some degree. In other words, time will be slowing down inside the capsule, where outside time will be going normal. In a black hole, in its gravitational field, any object um, will feel the time effect. Basically, the closer you go into the black hole, the stronger gravitational field, and time slows down. So the further you go, the more time slows down. If you reach the event horizon, then time completely stops. That is why a black hole is called the frozen star. Yes, the frozen star. And that is because time freezes. Time actually stops completely. If you didn't know that, well, that's a fact. Any scientist will tell you that. Anyway, um, that's because if it's an immense gravitational field or mass, whatever you call it, same thing happens with planets. For instance, here I have a little marble. It could be a sun, it could be a moon, a planet, anything that has mass. It bends time and space. And on the bottom, we have time and space. Basically, all the planets are on top of it, like a bed sheet, like a blanket. So the marbles create a dentation underneath, and that's basically underneath the space and time, or time and space, and that creates a dentation. So even the Earth itself, because of its mass, creates a dent in time and space in the universe. All the planets do, including the sun, including the moon, all the planets, even the black hole creates this dentation, but on a larger scale. Anyway, we have a machine that does that. But first of all, we know that I explained to you real quick how time slows down because of the gravitational field, the mass, and the black hole. Pretty much, if you're in a mountain, you live in a mountain, you're on top of the mountain, then time goes quicker. You age quicker because the mountain has mass, while your twin brother at sea level ages less. So basically, the one in a mountain that lives in a mountain ages a little quicker than his twin brother at sea level because of the mass difference. There's the more mass, the more you age, because in this case, I have an arrow here because the g-forces of the gravity pulls you down to the mass. So that pulling, or in this case pushing toward the mass, that creates that aging quicker effect. So we call that, I'll say that's a positive G's. Say it's positive G's. Same as this one, basically. So we have one Earth gravity, so we have 1G. So that's what this is. The mountain and plus the Earth is 1G. One Earth gravity plus the mountain equals more pulling or pushing this way toward the Earth, or the gravity of the Earth, or the gravity of the mass. So I call that positive G. So you could be one Earth gravity, two Earth gravity, three Earth gravity, whatever. But anyway, that creates a pushing, pulling toward the gravity of the mass. Now, in the black hole, you have a pulling apart, stretching your molecules. It's like trying to tear up your molecules apart. But that stretching of your molecules is what slows time. So if you have a mass, like a mountain, and this is a planet underneath, and then above it you have the same thing, a mountain and a mass of equal, then these two mass objects or mountains will pull apart, or try to at least, the molecules. One will go this way and one will try to go this way. So both in a body will try to go two directions, pulling effect, basically stretching your molecules. And this concept will actually slows time, same as a black hole. But you have to be conscious and understand that you have to pull the molecules through a certain point where time slows down. And there's a limit where you can stretch them. And as long as you don't go beyond that limit, then time will slow down. Okay, this machine will do that. This machine has got 100 pounds, 100 pounds cap or cover, and this is 100 pounds, and this is 100 pounds. This is the one-way entrance. These two occupants go in there, and these engines are separate. Each engine's on top of the other one. Each one rotates 100,000 Gs. I'm sorry, 200,000 Gs. So 200,000 Gs, 200,000 Gs. Let's say you have a total of 10 engines, and then the total cumulative G-force, in this case I have 100,000 Gs spinning 1 million Gs equals to 100 million pounds. Okay, so that's 90-something thousand tons or something. I don't know the exact number, but it's over 90,000 tons. But anyway, that's how much you can increase instantly at spinning G's. You could turn that 100 pounds instantly into either 200 if it's single, 200 pounds, or in this case 100 pounds times 1 million G's becomes 100 million pounds. Anyway, that's how heavy these things will be. So you need something strong enough so that this thing does not collapse. So yeah, you have this pulling effect on this 100-pound mass over here, 100-pound mass. So what it does is, part of it wants to go this way, the other part wants to go that way. So in the occupants, molecules want to stretch or pull both ways, go this way and this way. And if you're spinning them, these are 100 pounds, try and make it denser with denser material, just to equal the same 100 pounds on each side. Because remember, the thinner, it's different because not only that, the G-forces on the sides will be different than the inside. The inside is going to be spinning at different velocity than the outside. So that's why you need different thickness or heaviest of materials on each side. So be kind of getting close to spinning in the same way all the way around. Anyway, in that case, if you have this material denser by spinning, then also you want to create a pulling effect going this way and this way, pretty much all the way around. You want to create that pulling effect all the way around inside the occupants. So you create a time bubble where inside this bubble, the occupants molecules get stretched and time slows down for the occupants. So let's say you stay there, for example, 1 minute inside the time bubble. Everything outside, let's just pretend for this example, time outside will be maybe a day for every minute. And that's just an example. Let's say you spend here 10 minutes, maybe 10 days will already pass. So when you come out, you'll be 10 days in the future. You can go forward, but you cannot go backwards because it's just like when you have products in the freezer. The molecules in the freezer, actually the molecules slow down in the freezer just slightly. That's why it doesn't spoil that quickly. Also, in this case, your time slowing down, so you have suspended animation. So let's say you advance this to a higher velocity of G-force. So let's say you have 1 trillion G's, and then that'll be 100 trillion pounds on each side. So depending how many G's you have, you can increase the G's higher and higher to increase those 100 pounds to, let's say, 100 million pounds, or 100 billion pounds, or 100 trillion pounds. Just a matter of how many G-forces at the end you have this. So it could be it's just a concept and invention. And actually will work. The higher the G's, the more time will slow down. So you want to get this with more pounds or heavier mass, and the more G spinning, and that creates the more and more time will slow down. But anyway, for example, each motor is on top of the other one, and the motor is already spinning at 200 G's, while the other one starts spinning, but it's spinning on top of a moving surface. So the top one is going to spin faster than the bottom one. because it's moving on top of the moving surface, already moving when it starts spinning. So so the top one's always going to be spinning faster and faster and faster than the bottom one, even though they're all spinning at the same velocity, because the top one's going to be moving on top of the moving surface, already moving. It's going to be faster and faster and faster and faster. That's why I mentioned if it's moving at 200 Gs, the bottom one, the top one's going to move faster than the bottom one. Let's say 200 Gs faster, so that's going to be 400,000 Gs faster, and so on. So that's why it's accumulative. The more motors you have, the more Gs for each motor. It accumulates more and more, and that's why the velocity of Gs will increase exponentially. And the more motors, up to infinity, and you could always increase that into higher mass. This 100 pounds can be higher Gs depending on how many motors and Gs you have for each motor. Also, you could have one machine. It could be a 1 ton top, 1 ton on the bottom. The weight is, the numbers are just for example purposes. It could be higher weight, less weight. It could be higher Gs or less Gs. Few motors. It could be multiple motors. It could be 1,000 motors. It's just the energy is up to the design. The speed is up to the design. Basically, that's the way it goes. But this is my invention. This is a time capsule in reality, because it slows time inside a suspended animation. Imagine having a nicely cooked something, food, perishables, and keep them inside, and 100 years later take them out and still warm and hot, because anything in there will be preserved. Well, because time will completely slow down, turn to a point where it's actually better than a refrigerator. The whole body, the whole human, even if your person is injured, they can remain there for a period of time and still be in suspended animation. For them, it will be like maybe 5 minutes there, but the world might pass 5 years, 10 years, 100 years, 1,000 years into the future. But injured person come out when technology is more advanced, and they can have surgeries and whatever. But for other purposes, it's basically time travel forward in time. There you go, guys.